Hello students, myself Shekade, Assistant Professor, Department of Pharmaceutics in Dr. D.Y. Patil, Institute of Pharmaceutical Science and Research, Pimpri, Pune. In this video lecture, we will discuss about pellet. Learning objective of this chapter. Upon completion of the chapter, the student shall be able to understand the introduction of pellet. Students shall be able to explain formulation requirement for pellet, different process which is used for the pelletization, and equipments used for manufacturing of pellets. So first, in introduction, what is meant by pellet? So as we know that pellet, it is a solid dosage form. So it is a small, free-flowing spherical units ranging in various size, which is prepared by agglomeration of fine powder that is called as a pellets. Their size and shapes are allowed their administration as an injection and also for oral drug delivery system. Generally, the pellet size range is in between 0.5 to 1.5 mm in range. Why we are preparing the pellets? First objective of the pellet formation is taste masking. There are some drugs which are having unpleasant taste or bitter taste. So by forming the micro pellets, we are able to mask the unpleasant taste of that drug without lowering their bioavailability, especially in case of oral products. The second reason for formation of pellet is immediate release. As we are converting that fine powder into pellets, pellets forms and that leads to increase the surface area as compared to other traditional dosage form like tablets and capsules. So as the surface area is get increased, that dosage form get dissolved rapidly. If dissolution is faster, then the release of that drug from the pellet is faster. That means you will get the immediate release from the pellet. Next reason for the pellet formation is sustained release. Pellets are also used in the manufacturing of sustained release dosage form of some drugs because there are some advantages of the pellets, like they can extend the daytime and nighttime activity of the drugs. By pellet formation, we can reduce the dosage frequency of dosage forms. And pellets are more acceptable by the patient. So that means there we can increase the patient compliance also. So that is also the another reason for the pellet formation. Another reason is there are some drugs, they are chemically incompatible with each other, drug and excipient. So at that times, that ingredients are required to be delivered in a single dose. So in such cases, we can go for the formation of pellets. And pellets have very excellent flow properties. So due to that, that pellets we can conveniently use for the capsule filling. These all are the reasons are there so that we are preparing the pellet dosage form. The next point we are going to discuss the advantages of pellets. The first advantage is that pellets are responsible to increase the appearance of product. Second, coating of drug pellets with a different polymer, we can achieve the controlled release rate of drug. Then, as we previously discussed, that as we are forming the pellet, there is a large surface area is there, and due to that, the better distribution is takes place, better dissolution is takes place, and due to that, absorption is also takes place rapidly. So, for immediate release product, we can go for the formation of pellets. Then, chemically incompatible products, that also we can formulate in the form of pellets and delivered into single dosage form by encapsulating them. As well as pellets are going to ensure, or pellets having the very excellent flow properties. So it provides the flexibility in the formulation, development and manufacturing in form of various dosage form. So these all are the advantages of pellets are there. Reasons of pelletization. First, for the prevention of segregation of coagglomerated pellets or the powder. Then why we are going for the pelletization? That is, it gives a defined shape and weight so that the appearance of your product is also get increased. Then if you want to formulate the control release application or the control release dosage form, then also we are going to form the pellets. And pellets having the very good flow properties, so they can disperse freely throughout an area of GI tract after the administration, and you will get the maximum drug absorption from the pellet. And the side effect of pellets is very minimum. It doesn't affect on the drug bioavailability. So these all are the reasons are there, and for that purpose we are going for the pelletization technique. Now for pelletization, there are various methods or approaches are going to be used for the pellet formation. So as you can see, these are various techniques which are used for the pellet formation. First one is the agitation. Second one is the compaction, layering, and globulation. So in agitation, we can go for the boiling methods. This method is also used for the pellet formation. In compaction, either we can go for the compression, and extrusion speronization technique. Nowadays, this extrusion and speronization, this technique is most widely used method for pelletization. In layering also, we can go for the powder layering or solution or a suspension layering. And in fourth technique, we can use the spray drying or spray congealing method for the pelletization. So this is the elaborative methods are there which are used for the pellets formation. We will discuss one by one in detail. So first technique is extrusion or speronization. So as I said that extrusion speronization, it is most widely used technique for the formulation of sustained release or controlled release delivery system. And the main objective of this technique is to produce spherical pellets of uniform size with a high drug loading capacity. So as you can observe in the diagram, the extrudeds are there, which we form by the extrusion technique. Then the breaking of that extruded takes place. Then speronizing it takes place, and finally you will get through the speronizer technique, you will get the finally spherical shape pellets. So in extrusion and speronization process, firstly we have to form the weight mass. In that case, firstly we will take the all ingredients, that is your excipient and API, mix it well, then add a binder solution and you will get a liquid mass or weight mass. That base weight mass we are going to pass into the extruder. Through extruder, you will get the extruded of that weight mass, and then that extruded we have to put into the speronizer. At specific RPM, we have to rotate that speronizer, and that weight extruded will get converted into the weight spherical shape pellets. Furtherly, you can go for the coating of that pellets also. So by this way, we can be form pellets by this extrusion and speronization technique. So as I said, that is in extrusion speronization technique, first technique is your dry mixing of ingredient, then weight massing formation, extrusion to get the extruded, then speronization to round off those extruded which are in rod shape, and then finally by speronization you will get the spherical pellets that will go for the drying and screening to get the uniform size distribution of pellets. So this is the overall method of extrusion and speronization which is used for the formation of pellet. Now in extruder or in extrusion, there are various type of extruder are used to form the extruded. First, that is screw feed extruded. So mainly it is get available in two format, that is axial extruders and radial extruded. Now there is a slight difference between the radial and axial. So as you can observe the first figure, so this is the axial extruder and the another one is radial extruder. So in axial extruder, the die plate which is positioned in axially. So mainly in this extruder, it consists the feeding zone. So this is your feeding zone. This is your compression zone. And the last one is your extrusion zone. So from feeding zone, I'm going to place my weight mass. Then that weight mass get compressed into the compression zone. And through extrusion zone, you will get going to collect the extruded with the help of this die plate. So it is this die plate, it is attached axially. So that's why it is known as the axial extruder. The second one, that is radial extruder. So here this die plate, it is mounted around the horizontal axis of the screws. That's why it is known as a radial extruder. Then the another type of extruder is gravity fed extruder. Now in this gravity fed extruder, here two counter rotating cylinders are there. Again, this extruder it is also available into the two forms. First one is a rotary cylinder extruder, in which, as you can observe in this diagram, one cylinder is a hollow and perforated, whereas the other cylinder is a solid. From this feeder, we are going to feed our material, that is weight mass, and that will going to compress or press in between this roller. And these two, both cylinders are always in a rotating state. And the another type of extruder is your rotary gear extruder. As you can observe in this diagram, so this is a rotary gear extruder. So it consists of two hollow counter rotating gear cylinder, which is having the counter board holes. So through these holes, you will get your extruded. There is one more extruder is there. So it is a very oldest type of extruder. Nowadays, it is not going to be used to form the extruded. So in this extruded, as you can observe, so this is the cylindrical structure is there. This is your piston. So through this feed form inlay, we can feed our material. As we are going to apply some pressure, so this piston shows their movements, and this material will going to be forced in forward direction, and with the help of this die plate, you will get your extruded. So in this way, it will work. So by using various type of extruder, you will be able to form the extruded, and that extruded will going to be placed into the speronizer for speronizing purpose. So this is the steps which shows the formation of pellets by the speronization process. So for by using extruded, you will get your extruded, which is in a like this, that is cylindrical extruded. Furtherly, the breakdown of that cylindrical extruded will get in form of cylindrical rods. As we are placed into the speronization, it in a rotation state. So due to that, their ends will going to be converted into the rounded ends. Okay, as you can observe the difference between these two diagrams. Then furtherly, the dumbbells like structure will form. Again, further rotation, it will get converted into the ellipsoid particle, and then finally the spherical shapes of pellets you will get by the extrusion and spheronization technique. So whatever the pellets we will get by the extrusion and spheronization, they have their properties, like from the extrusion and spheronization, whatever the pellets we will get, that are dust-free pellets, that is having high sphericity, good spherical shapes, free flowing, good compact structure. They are low hygroscopic in nature. They shows the high bulk density, low abrasion, narrow particle size distribution, and smooth surface. So these all are the features having that pellets which we obtain by the extrusion and spheronization technique. I hope you all are clear with this. Thank you.